Welcome, students, to vertical asymptotes and other vertical discontinuities, which is on page 3 of your notes. A vertical discontinuity is anything that makes the denominator equal 0. It could be an asymptote, which are those barriers that we talked about last week, or it could be a hole, which we saw one example of on the assignment last week. So as we've already discussed, if your equation looks like this, it's in transformation form where this is your up and down and this is your left and right, then your vertical asymptote is right here. This is your vertical asymptote. And don't forget to flip the sign from whatever you see here. However, if your equation looks like a single giant fraction like this, which you saw some, and last week you had to do them by graphing and looking at the graph, there actually is a way to figure out exactly where the vertical asymptotes are. So the first thing you're going to do is set the denominator equal to 0. So remember, the denominator is the bottom of the fraction. That is where we cannot have a 0. So I'm going to see what values will make it equal 0, and then I know that those are the values that are not allowed. So I'm going to take my denominator, x to the third minus 2x squared minus 5x plus 6, and I'm going to set it equal to 0. So now you have to solve this or factor this somehow. I recommend just using polyroots, which we've done in this class before. It's menu 331. So hopefully you remember seeing this before. Now remember to change your degree to 3, because that is our biggest exponent, and then leave this on real. And then you're going to put your coefficients in. So 1, -2, -5, and 6. And then press enter a few times. And it's going to give you some x values that cause the denominator to become 0. So I'm going to write those down. So I got x equals -2, x equals 1, and x equals 3. So now I have to find out which ones are asymptotes. So which ones are these barriers right here? And which one is going to be a hole? Spoiler alert, it's the 3. Which one is going to be a hole? Which is just a gap in the graph. It's this one point that is undefined because there is no corresponding y value. So you could just look at the graph and tell. Some of you will probably choose to do that. So you could graph it, which is what I did here. I did that here for you, so you can see. -2 is an asymptote, so that's an asymptote. +1 is an asymptote, and +3 is a hole. The other way to tell, which I think a few of you might like, is to check the numerator. So the way you check the numerator is this. So my numerator is x minus 3. X minus 3. I'm going to plug each of my suspicious x values into this and see what I get. So I'm going to plug in x equals -2, x equals 1, and x equals 3. So plug in each x value into the numerator. So then I get so instead of x, I'm going to put -2 minus 3, and that is -5. Then 1 minus 3, that's -2. And then 3 minus 3 is 0. Once you do that, anyone that comes out as 0 is going to be a hole. So x equals 3 is a hole, and we could tell that from the graph. We already saw that. X equals 3 is the hole. Any of the others, if it comes out as anything else, it is an asymptote. So as you can see from the graph and from checking the numerator, x equals negative 2 is an asymptote, x equals 1 is an asymptote, and x equals 3 is a whole. So let's try one more together on the notes. So find all vertical asymptotes and discontinuities of the function, right here, and then we're going to give the domain. So step 1, set the denominator equal to 0. So I'm going to take my denominator, x to the third plus 4x squared plus x minus 6, and just say equals 0. And then I'm going to use whatever method, but I suggest polyroots is going to be the fastest, to find out what x values make that 0. So, menu 3, 3, 1. This one is going to be degree 3 also. Leave it at real. And then put in your coefficients. So 1, 4, 1, and negative 6. Okay, so it tells us the 3 suspicious x values that we need to check are negative 3, negative 2, and 1. So let me write that down. So x equals negative 3, x equals negative 2, and x equals 1. So I now need to check and see if those are asymptotes or wholes. Now for those of you who like the graphing method, I've already got it graphed here for you. So here's the graph. Well, let's see if I can clear that up a little bit. Not really. There, it's a little easier. All right, so here's my function. You're going to plot the whole thing, not just the denominator, the entire thing. And then you can see from the graph a lot easier where the asymptotes are. So you already know to check negative 3, and it looks like negative 3 is an asymptote. I'm going to go ahead and label that. Asymptote. Asymptote. And then let's see negative 2. Here's negative 2. I am not seeing an asymptote there. I'm not seeing a vertical asymptote. So I would suggest going to menu 5.1, which is trace, and then type in your suspicious number. So I'm negative 2. So x equals, in fact, you can just type negative 2. You don't have to type x equals. And it'll pop up. And sure enough, negative 2 is undefined. So that means that's a whole. There's not a vertical asymptote there. It's just an undefined value, so it's a whole. So I'm going to label that as a whole. And then I have to check x equals 1. So check my x value of 1 right here. And we can see that the graph kind of goes vertical there, so it's a vertical asymptote, or tries to go vertical anyway. Appears to be. So we know that that's an asymptote as well. Okay, so by graphing, we did figure out asymptote, whole, and asymptote. Now, for those of you who like to test the numerator, I'm going to just show that too. But just remember, you don't have to do both. Just have one that you are comfortable with. So my numerator is x plus 2. X plus 2. So I have to test my 3x values in here. I'm going to plug them in for x and just see what I get. So I'm going to take x minus 2, so I'm going to take a negative 3, plus 2. I'm going to take a negative 3 plus 2, which is negative 1. And remember, if it's not 0, that means it's an asymptote. Which is what I got here. Yay! Woohoo! Then I'm going to try negative 2. So negative 2 plus 2. Oh, that's 0. So this one's a whole. Which remember, we found that out from looking at the graph, that negative 2 is indeed a whole. And then finally, I'm going to test the 1. So I'm going to take 1 plus 2, which is 3. And since that's not 0, it means it's an asymptote. Which again, we saw on the graph. So you got basically take the denominator, set it equal to 0, and do polyroots in your calculator. and then check those values that you get either with the graph or by checking in the numerator and plugging them in.